Does everybody have the ArduiNO software downloaded on said computer? Alright. So there's a section there, and I'm going to go ahead and go there. Hold on. Going ahead a little bit. Alright. So if you haven't done it yet, you done messed up. Because you guys were supposed to be prepared. So go to arduino.cc/en main software, right? Get the IDE, which is going to be the programming interface that we use to control Arduinos. Stick it in the USB thing. And it should say installing a driver, and then it should be like, driver failed, and you'll be like, what the hell, Elliot? So then go to that website, ftdiship.com/drivers.vcm, right? The directions for downloading and installing things are below it, but all you really need to do if you have a Windows device, which it looks like everybody here has, is click the exe file in the comments. It says download the executable. Alright. And then eventually once you download it and whatnot, it should make a little flashy thing. You should run the software on your computer, and everything is running well. Yeah. Don't pay attention to 1 through 3 in the middle there. That's just kind of I swear I'm not getting a virus on your computer. Maybe not. But if you downloaded the ArduiNO.cc software and whatnot, and you click the little icon, it should come up with something like this, right? But this is all the basic installation, the setup, and programming interface. You guys can use this for years to come. The little secondary thing, the FTDI chip, that's specific to these kits, right? So they have a specific driver to these kits. Otherwise, you guys can use any of those blue Arduinos with just the regular interface. Cool? And we didn't have enough of the little blue ones in order to make it work, so I don't think so. Yeah. Who's done? Can I get a hell yeah if you're done? Okay.
I didn't install the drivers, but this is working. The IDE is working.
Oh, the IDE is working? Yeah. Okay, cool. Go ahead and install the drivers.
Oh, just right
there. Yes. Yeah. So, once you're done, all I want to hear is a hell yeah, and then we can proceed. If you're already finished, I'm going to start talking and stuff. You guys know where to go, what to do. Are things running, going along? Do you want me to keep this up? Bueller. Alright, keep it up a little bit. Alright.
Let me take a picture of it.
Sure. No, don't worry about it. Don't worry, I'll keep it up. So what the hell is an Arduino? Right? Who knows? Anybody know what it is already coming in here?
Some sort of yeah, there you go. This is
Awesome. Microcontroller, right? What does a microcontroller do? Yes, yeah, it runs commands. What a microcontroller does is it takes an input and changes it to an output, right? It's a simple input-output device. It takes one form of something and changes it into another form of something, right? That could comprise data from an EEG, for example, and then changes it into an output on a computer screen. That could comprise a piezoelectric sensor that measures force and changes it into an LED that lights up in a certain kind of way. That could be any kind of input versus output. If you're just coming in, you can share somebody else's stuff.
Thanks, I appreciate it.
Okay,
I'm in the wrong place.
So, is everybody somewhat set on this slide? I'm going to go back to the beginning. So what the hell is this thing? This is an Arduino. An Arduino comprises the actual integrated circuit, which is the small little square thing, and a hell of a lot of pins that are all input outputs, all voltage supplies and other things like that. This right here is a voltage supply, and then this is what you use to program it. And so it has onboard memory, processes things at about 40 megahertz, which is somewhat fast, and people love Arduinos because it's completely open source hardware. That means you can make this yourself online because they have all the components up. They have the actual circuit board on there that you can then print out and then put components in. They also have the programming interface, the IDE, completely free online. So a bunch of example code. The community is really, really solid. It's really fun to use, and you can use it for practically anything because it takes stuff in the world and turns it into different stuff, right? So who has an Arduino project that they're thinking about? Any examples? Yeah, what's your Arduino project, man?
Taking in mock-up brainwave data and characterizing it into one of a number of different.
Got you. Like, what are some example outputs?
Just various character strings.
Cool, cool. So you'll be able to, you can take multiple inputs too and turn them into multiple outputs. You can take one input and turn it into multiple outputs. You can take one input, one output, whatever. Anything in between, you just take stuff to different stuff. So doing this can microcontrol the world. This right here is an open PCR machine, linearized chain reaction. They used Arduino to build this. This right here is laser lights, a glove that uses sensors, flex sensors, in order to control different things, robots, the entire bar system, tap system, and you can control the world, microcontrol the world. So, these are the steps that I want you guys to do. If you haven't done this already, go find the cool little infinity minus plus icon, click it, open it up. You should end up with a blank sketch. It's not going to say May 13A. It's going to say some weird random number. Don't worry about it. And then we're going to have a dance party. That's what we're going to do. So once you've done that, start dancing. Just so I know that you've done that, we can move on. Yeah? Yeah? You good? You good? Get like the shoulders going. There you go. Faster. You can make it slower. You can do different things like that by just changing the interval variable. Right? So next is the setup. So what you want to do after you declare the variables at the very top, you write below it void setup, parentheses, parentheses, curly braces, and then stuff, which we're going to do later. Okay? And then next, couple spaces, void loop, parentheses, curly braces, stuff. So what happens in Arduino IDE is that you set up all the variables first that you're going to use, right? And then in the setup, you basically say, what's the output, right? What is the input, what's the output, right? You can say where the input's coming from, you can say where the output's coming from, right? You could declare the variables within the setup, but it means that there's a couple things you can't do with them, right? So normally, just the general thing is declaring the variables outside of the setup. That's my computer, it's just...
Can you go back one real quick?
Yeah, of course, of course.
Okay, good.
You good to go? Yeah. Such code, man. Anybody have any difficulties thus far? Alright, good to go? Alright, so now, within the setup, make a little bit of space, right? What we're going to do is determine what the output is, right? And so, pin mode is the setting that says whether something is an input or an output, depending on where it's coming from. So you can do that for any of the different kind of pins. You can say, all right, well, I want to blow on a speaker and have that voltage be my input, right? And then that could come from whatever you declared as your pin, right? So we said LED pin was 13, right? So 13 is going to be our output. But let's say we wanted to blow on a speaker and have it control the output, right? So we would need two different pins, one for the input, and we'd say like the input's 9 or 7 or whatever, right? And input, and then pin mode LED pin, which is 13 in the output. Make sense? Kind of? Talking in circles? Anything kind of confusing? Right. All right, so I'm going to move on to something very complicated, and I'm going to explain as I go, right? So this right here is the code that I want you guys to copy on in, and it'll run it. But I'm going to explain it so that you guys can modify it and play with it if you do. So this is the code within void loop that just runs constantly, right? So this is what constantly checks and updates each time it loops. It's how Arduinos work and constantly update themselves. right? So what you're doing is you're basically creating a variable called current millis, right? What is your current time in milliseconds? And then setting it as an empty variable, right? Which is why it's unsigned. It's not anything yet, right? It's just an empty variable, right? Next up, you do an if-then statement, or an if-else statement, really. So you say, if whatever your current millis are, which is nothing right now, starting out, minus what your previous millis are. And remember, we set up previous millis in the initial stuff, right? If all of that is greater than the interval, which is 1,000, right, then you do all this. So for if-else statements, what you do is you say if you have a section where you have some sort of modifier, some sort of operator, right? And normally it's less than, it's equal to, it's greater than, other things like that, right? Just for numbers. And then you put a curly brace, right? And within the curly brace, you can put additional qualifiers. You can say, if all of these things are true, then do this. These things are false, do this. There's a lot of things you can do with if-then statements. It's binary operators, right? So if something is blah, 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 then do blah. So on the inside, right, you save the last time you blinked the LED, right? And this is all just like logically. You're supposed to count the amount of time in between when the LED blinks, right? And then save the last time that it blinks. So you start over, right? So that's just saying that after it is above the interval, after it's over 1 second, which is the time that we set right now, 1,000 milliseconds, 1 second, right? If it's over 1 second, start over, set it back at 0, right? So that's what that statement says, right? The next statement is another if-then statement. So if the LED is off, turn it on, and vice versa, right? So this is basically saying, all right, well the LED is off and I want it on. The LED is on, I want it off. So if the LED state is low, meaning that's not on, turn it high. Else the LED state is low. So it's constantly off unless it's on. Makes sense? Yeah. There's only 2 states that you do. Right? So all of this is within, let's wait 1,000 seconds before turning it on. Right? And then once it's on, let's wait another, let's not 1,000 seconds. Let's wait 1 second or 1,000 milliseconds and then turn it on. Right? Then let's wait another second and turn it on. That's all this is doing. Right? But logically, it's like, and computer science, blah, 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 right? And then finally, you do the digital write, which is what we did for all of the, digital write is for all of the non-pulse width modulation, right? So for all the pins without the little squiggly, you say whatever the pin is, whatever the state is. So the state is either on or off. And so if you write all this out, and you have all your curly braces right, now I want you guys to click upload, which is the little arrow in the corner. It should flash a little bit, and then there you go. It's on and off for 1 second. So you can vary the interval now by having the interval variable change. Yeah, like you guys are doing right there. So you can change it so that it's faster or slower or different things. What this is a logic circuit, basically, that allows you to say, if something is this amount of time, do this, right? So you guys can take time intervals and make it do something dependent on the time it takes, right? So this doesn't have to be applied to LEDs, it could be applied to motors, it could be applied to anything, right? As long as the time interval is a certain amount, you make the output a certain way. So is anybody having trouble or getting it to blink or do different things? Not really. Yes?
I have a question. So how often is it checking this? How often is this loop running? It's just continuously running, and like every millisecond is checking?
Yeah, practically. When you get down into doing like single milliseconds, it gets really difficult for the circuit to run that fast, right?
Yeah.
It operates at like 40 megahertz, I want to say, which is pretty damn fast.
Okay.
But the loop itself is taking the time for 1 second, right? So it's saying when 1,000 milliseconds pass, then you do this.
Okay.
So it is checking it over and over and over again, but it does all of these before finishing.
It does all of this before, okay.
And then it starts over.
Okay.
So it'll run 2 seconds is how it's running. Yeah.
Yeah.
There are certain shortcuts. If you guys do Control A, Control T, it actually formats it all for you.
How do you stop it?
How do you stop it? For Arduinos, there's ways you can either hit the reset button. Yeah, just press it. And if you press that. So you can either hit the reset button to stop it. You can also unplug it, which is oftentimes what I do. But Arduinos have a certain amount of memory on them, so that code is now uploaded into there, and it can run independently of your computer.
So then where does the voltage source come from?
The voltage source comes from your computer, actually.
But if you, yeah.
If you unplug the computer, there's a voltage in the computer. So that little black.
It didn't do anything.
Yes, I believe the motor requires a certain voltage.
So it's different, probably higher than what it's currently supplying.
Yeah, check the book though. The book actually runs you through a bunch of different examples. It's really, really valuable.
Okay.
You can find different things on using flex sensors, motors, all sorts of different things. All right, so next, right, after you guys have made it blink, and it seems like most of you are successful in trying to play around with that, they're trying to get 2 blinking alternately, right? So it's kind of like a siren. Next is make it fade, right? And so this is going to be using pulse width modulation, which will allow you to control the percentage of voltage getting to the LED, starting with 0, proceeding to 100, and back again, right? So my kind of challenge to you guys is to see if you can get both going at once within your code in some kind of way, right? Getting 2 outputs for the code that you're writing. Getting it both to blink and fade. See if you can do that, right? So this is setting up to use pulse width modulation. This is saying that your starting variable is pin 9, which is where your output's going to be, right? Output for the LED is 1. Similar circuit setup, you use another resistor that's a 330 ohm resistor, and you connect it to 2 wires, right? But my challenge to you is I'm not showing you the circuit diagram, I'm not doing any of that. Try to hook it up so that it works at the same time as the blinking. Cool? So this is the starting variable. You want your LED pin. Actually, it should be called something else. It shouldn't be called LED pin because you've already named something LED pin, right? So one should be named LED pin A, or LED pin blink, or LED pin fade, right? Different things like that. All right, you guys got that? What kind of way you declare your variables is something different? Cool. All right, the void setup is still the same, but this time you add in another line that says pin mode, LED pin, whatever you named it, right? And then your output is also output. So you have 2 different outputs now within setup, right? And then what I want you guys to do is do a loop, right? So what this is doing is it's going through a for statement. So for a certain integer, which is fade value in this case, right? You start at 0. Fade value starts at 0. Then you're going to increase it up to 255. 255 is the limit. 255 is also the maximum value for pulse width modulation. Right? It goes from 0 to 255. Right? Next up, what you're going to do is the fade value is going to be incremented by 5 every single time. Right? And then it's going to set it back equal to the fade value. That plus equal sign just means that you're going to add 5 to the fade value and then set it back equal to the fade value. Right? So if I had plus equals 1, what would happen? Yeah, exactly. So if I had plus equals 1 and it went through 3 times, what's my new fade value? modulation, it's an analog output, right? So what you're going to do is analog write, and then whatever you named your pulse width modulation in, whether that's a fade or whatever it is, and then fade value. So the fade value is that value from 0 to 255. You do this differently than the digital write because it's not high or low, it's not binary, it's a discrete value, right? And then what you want to do, and this is a function that you could use to make it blink also, instead of having it wait a specific period of time and make it blink, you could also use the delay function, which simplifies things. But you're going to delay it a little bit, just so that you can see it as it fades. You know, it waits a little bit in each value, rather than just incrementing really, really, really fast. So it'll be a nice, smooth fade. You could actually delay it even more to make the fade longer, if you would like. Okay? And so then you put that in brackets, and this is all within for loop. There's some problems with brackets. If you click next to a bracket, it shows you its pair. So that's an easy way to troubleshoot. Troubleshoot the code. Alright, so now, after you've done from 0 to 255, well, you have to go back again, right? So this is basically an opposite for loop, going from 255 back down. So it'll fade in and go really, really bright, and then fade back out. Okay? So this is the exact same loop, just starting out at 255, saying that fade value is greater than or equal to 0 rather than less than or equal to 255, right? And then saying it's minus equals 5. So you're taking away 5 each time, right? So for loops are a really, really powerful way to loop something, right? You're doing it within the void loop, but for a for loop function, you can increment things in certain ways. Like for example, if you have a RGB strip of LEDs, which is a project that I did before, red, green, blue color strip, you can say, all right, well the red value will increase this much as the blue value decreases this much. You can say the blue value increases this much as the green value increases this much. And you can get an interesting combination of different colors depending on what you control in that. So let me know if you need any help or if you're...
Is this kind of the same loop as the original blinking, so you blinking and then the fading? So you have it blink and then fade?
Yes.
Okay.
Yeah. So it's within that loop. What you need to make sure though is that the if-then statements and the blinking is discrete from the for loop. So it's not within each other. Like it does one and then the other. So that's our deck, guys. If you guys have any questions about ArduiNOs or are interested in doing other things, I would recommend checking the book. There's a hell of a lot of really good things there. Here's some additional resources that I found for you guys. If you guys are really artistically inclined, there's a language called processing that works the same kind of way. But it works with ArduiNOs, with other things, whatnot. Go to arduino.cc for more info, and then there's a playground and forum, and so you can get a lot of good stuff there. I was trying to find a specific like medical one for ArduiNOs, but to no avail. Anyways, I am here the rest of the day and tomorrow, so if you guys have any questions or just want to geek out about things,